Okay, now let us look at a few standard identities which will be of very extreme help when we try to simplify some of our calculations later on. The first identity that we are going to look at is a plus b multiplied by a plus b. That is, or you could also write it as a plus b whole squared. Now, all we are going to do is just try to simplify it and multiply like we did earlier. So essentially, I can write a plus b whole square as a plus b multiplied by a plus b. And this essentially is a binomial multiplied by a binomial, right? So this is an expression that has two terms, a plus b, and yeah, multiplied by itself. So we use the distributive law of multiplication, that is, this a is multiplied by a first, and then this a is multiplied by b first. Similarly, this a is multiplied by this b is multiplied by a first, and this b is multiplied by b first. Okay, so that is one way you could do. Or the other way is you just take this a and multiply it entirely by a plus b. Similarly, you take the b and multiply it by a plus b. So what I have done here is taken the another method. I'm saying a, take the a and multiply it by a plus b plus b multiplied by a plus b, and then this is essentially a monomial multiplied by a binomial. That's the step 2. So we solve this. So a times a gives you a square, a times b gives you ab, b times a gives you ba, and b times b gives you b square. And the third step is to simplify the like terms. So what are the like terms here? AB and B are like terms. Remember that AB is equal to BA. So we have a square plus 2ab, that is ab plus ab gives us 2ab plus b square. So this identity comes out to be a plus b whole squared is equal to a squared plus 2ab plus b square. So here are the three standard identities that would be helpful to remember them, and we will see applications of these in the coming video. So the first one is a plus b whole squared equals a square plus b square plus twice of ab. That's the first identity. What happens if we have a minus b whole squared? So a minus b whole square equals a square plus b square minus 2ab. Now just note the difference between a plus b whole square and a minus b whole square is the fact that the sign of the coefficient of this term changes. So it changes, it was plus 2ab into a plus b whole square, and it became minus 2ab into for the a minus b whole square. The another important identity to remember is when you are multiplying sum and difference of the same variable. So it's shown as a plus b multiplied by a minus b. Now note that this a and b could be terms, okay? They could be terms, they could be numbers. It's just in general applicable for anything that is there. You know, you can substitute for a and b. So a plus b multiplied by a minus b gives you a square minus b square. So this is what you get. Very useful to remember this these three identities. Another useful identity to remember is x plus a multiplied by x plus b. So you can see that this is a common variable, and a and b could be, you know, different terms, or x is a common term and a and b could be different terms. And when you simplify this, it's again a binomial multiplied by a binomial. You get x squared plus a plus b, the sum of a plus b, the sum of two these numbers, and multiplied by x plus ab. Okay, it is a very useful exercise for you to prove these three identities along the lines of how we proved a plus b whole squared. Again, you just have to use the basic principles of a binomial multiplied by another binomial, as we have already discussed in earlier videos.